All right, let's talk about something that sounds completely impossible, like it's straight out of a sci-fi movie. A rocket that runs on water. I know, it sounds crazy, but the science behind it is actually pretty amazing. And the engineering journey to make it happen is one heck of a story. So that's the real question we're diving into. Is it actually possible? Can a DIY project, in a garage, really turn plain old water into a propellant powerful enough for a metal 3D printed rocket? Well, let's find out. Okay, so first things first, before we get into the how, we've got to understand the why. What is it about H2O that even makes it a potential rocket fuel? Well, the secret is locked inside its chemical bonds, and there's a neat trick to get it out. And that trick is called electrolysis. Honestly, it's way simpler than it sounds. You basically just stick two pieces of metal in water, hook them up to a battery, and the electricity literally tears the H2O molecules apart into hydrogen gas and oxygen gas. The best part? It gives you the perfect mix of fuel, the hydrogen, and the oxygen you need to burn it. And when we're talking about fuel, we're talking about some serious power. Just look at this. A single kilogram of hydrogen packs a whopping 34,000 calories. For comparison, that's more than 3 times the energy you get from the same amount of gasoline. It is an incredibly powerful fuel. So if hydrogen is so amazing, why aren't we using it for everything? Well, here's the massive catch. It's the lightest element in the universe, which means it's not dense at all. Even when you chill it down to a liquid at minus 250 Celsius, you still need a giant 10-liter jug just to hold 1 kilogram. That's why the idea of making it on demand, right when you need it, is so brilliant. And this whole challenge, making fuel on the fly, led the creator to this really ambitious, really out there idea. He was going to design a super efficient generator to pair with his custom-printed metal rocket. And the heart of this design was a truly beautiful and complex mathematical shape. See, to build the perfect electrolysis generator, you're chasing 2 things. First, you need a massive amount of surface area for the reaction to happen on. And second, you need your positive and negative electrodes to be incredibly close together, but without ever touching. That's the key to efficiency. His solution? A gyroid. This thing is just wild. It's this infinitely repeating 3D lattice that was actually discovered by a NASA scientist. And for this project, its most important feature is that it naturally divides any space it's in into 2 completely separate, perfectly intertwined volumes. Now, this is the really clever bit. The genius move isn't to use the gyroid itself. Nope. Instead, you take a solid block and you digitally subtract the gyroid shape from it. What you're left with are these 2 perfect interlocking lattices that get super close but are physically separate. These become your electrodes. Just brilliant. Okay, so the theory is elegant, right? But now it's time to actually build the thing. And this is where that beautiful idea runs headfirst into the messy, unforgiving world of real-world chemistry. Making this thing was a huge process. First, it was 3D printed with incredible detail using resin. But resin doesn't conduct electricity, so it had to be painstakingly coated in conductive copper. Then, to top it all off, a thin layer of silver was added to protect the copper from the sulfuric acid needed to make the water conductive. And at first, it worked. It worked amazingly well, just churning out tons and tons of gas. But then, just minutes into the test, this mysterious red sludge started forming, just covering the beautiful silver lattice and clogging up the whole generator. What on earth was going on? So after a bit of digging, he found the culprit. And it turns out that even though silver is totally fine with sulfuric acid, it reacts really badly with pure sulfur. And what he didn't expect was that the electrolysis process itself was breaking down the acid and releasing pure sulfur, which then created this non-conductive gunk all over his electrodes. He even had a backup lattice ready to go, tried it with a different chemical, and it failed too. It's at this point you just have to laugh, right? The gyroid generator, so perfect on paper, was a total bust in reality. But sometimes total failure is the best teacher. Because hitting this wall forced a major realization. The super complex gyroid wasn't just a pain to make. It might not have even been the right shape for the job to begin with. It was time to pivot. And here's the big aha moment. He realized he'd been way overthinking it. The most efficient way to cram a ton of electrode surface area into a cylinder isn't some fancy, complicated lattice. It's just stacking a bunch of simple, thin discs with a tiny gap between them. And when you put the two ideas side by side, it's just night and day. The super complex Joyride gave him 132 square inches of surface area, and it failed. The new, dead simple disc design, it easily matched that surface area with way less complexity, and it actually worked. So the new generator was just 30 stainless steel discs, all cut by hand. But here's the really clever twist. He used 3D printed gyroid shapes as the spacers between the discs. They gave the thin metal perfect support while leaving tons of room for the gas to escape. A perfect use for a failed idea. And this simple design, it was a huge success, pumping out an insane amount of gas. So with a fuel generator that finally worked, it was time. Time to connect it to the rocket engine and see if this thing could really, truly burn water. And the final setup is just a work of DIY art. You've got a tiny little computer and Arduino running the whole show. A custom spark plug he made from an IKEA straw provides the spark. And of course, you've got critical safety gear, like a flashback arrestor so the flame doesn't shoot back into the fuel tank. And then, the moment of truth. He hits the switch and it works. The rocket just roars to life. You can hear it's not a smooth burn. It's a series of powerful, deafening, controlled explosions. He actually did it, a rocket that runs on water. But in the world of engineering, solving one problem often creates a brand new one. And this was a big one. The generator was so good at its job that it was pulling a mind-blowing amount of power, over 400 amps of current. It was so much that it completely fried 2 high-capacity batteries in just a couple of tests. And that's where we have to leave this engineering story for now. He solved the fuel problem, which is incredible. But in doing so, he's basically created a whole new monster of a problem. How on earth do you power a machine that's this hungry for electricity?